Hey guys, welcome to another lecture from ecopoint. In the series for probability and statistics, we have been working on the distributions. And I have worked with you on the basic distributions, binomial, geometric, and hypergeometric. Today, we will be talking about something called the negative binomial distribution. And I'm going to talk to you about how it is related to the geometric distribution. So what is a negative binomial scenario? The negative binomial random variable and distribution are based on an experiment satisfying the following conditions. What are the conditions? The experiment consists of a sequence of independent trials. Each trial can result in either success or a failure. The probability of success is constant from trial to trial. It doesn't change. That means it's a with replacement. You have a fixed probability of success on any trial, and that is fixed as, say, P. I could be 1, 2, so on and so forth. Now, the experiment continues. The trials are performed again and again until a total of R successes have been observed, where R is a specified positive integer. Now, understand here how similar this is to geometric scenario. In geometric, what we said, the number of trials that have to be performed until the first success occurs. But here we're talking about until R successes happen, okay? That's the difference between the two. The random variable of interest is, it could be quoted as, actually it could be quoted in two ways. You can take the random variable X as the number of trials needed until and including the first success, not the first, the rth success, the rth success. It could also be taken as the number of failures that precede the rth success. If you observe, negative binomial distribution is just a generalization of the geometric random variable, in the sense that in geometric random variable, we talk about the number of failures preceding the first success, wherein in negative binomial, we are talking about the number of failures preceding rth success. Keeping what our random variable is here, let's try to find out the probability. So what will be the PDF or PMF? Probability distribution function or the probability mass function would be defined as probability X equal to, say, X. Now, when you're saying probability X equal to X, what is this X? This is the number of trials needed to get R successes. And what you need to understand here is, when you get the rth success, this process will stop, because we are just talking about the failures prior to the rth success or number of trials needed to get R successes, okay? Number of trials needed to get R successes, in case that is X. तो इसका मतलब है क्या हो रहा है? जो लास्ट आपका ट्रायल है, दैट इज X trial, okay? X trial has to be the rth success, because when I get rth success at this trial, तभी तो ये पूरा experiment खत्म हुआ. Otherwise, अदरवाइज तो R-1 सक्सेस तक रहेगा ना, हम RH सक्सेस पर कैसे आए, RH सक्सेस पे ऐसे आए कि द लास्ट ट्रायल इज गिविंग मी RH success. And why would I go beyond that? I will not go beyond that in my trials, right? I will take the trials only for R successes. So X trial, the exit, the last trial is the RH success. Okay. Now, RH success comes with probability, say P, as we wrote in the assumptions. Okay. Now, prior to the R successes, the RH success, prior to the RH success, I need R minus successes anywhere. I need R-1 successes, more successes, right? Because I first spoke about the RH success. That's just one success out of the, total R. So I need R-1 more successes. So that can occur anywhere before the last trial, right? So if I take away this last trial, I am left with X-1 trials. Out of the X-1 trials, in any of the R-1 trials, I can get my remaining successes and they will come with the probability P. So R-1, because P into P into P, R-1 times, right? That I'm taking successes R-1 times, right? Now, total number of trials are X. अब ऐसा तो नहीं है ना कि सिर्फ लगातार सक्सेस ही आती रही आर सक्सेसेस, जरूरी नहीं है ऐसा हो, राइट? तो कुछ ट्रायल्स में सक्सेस आई, कुछ में फेलियर्स आया, कितने में फेलियर्स आया? सो फेलियर्स की प्रोबेबिलिटी है 1 minus P and the remaining positions. What are the remaining positions? X में से R positions have gone for successes because I needed R successes. So X में से R निकल जाएगा जब, तो X minus R बचेगा. X minus R failures भी तो होंगे ना. This is when I am taking X to be the number of trials needed to get R successes. So the probability of me taking X trials in order to get R successes, including the RH success, is equal to X minus 1 CR minus 1, because these are the places, this is the number of ways in which I can choose R minus 1 places for R minus 1 successes. Why am I doing that? Because the last trial is definitely a success. That's why we're stopping there. So in total, I have R successes. Once you will combine this, you will get R successes. And multiplied by 1 minus P to the power X minus R. So hence what we have X minus 1 CR minus 1 minus P to the power X minus R into P to the power R. This is when you are taking the number of trials needed to get R successes, including, so I'm not talking in terms of failure right now. I'm talking in terms of successes. There are two ways, even in geometric. If you please go back to the geometric random variable video to revise that. And I have there spoken about how you deal when you take failure into consideration instead of success when you are taking down your random variable. Okay. In fact, suppose we talk about, let's take values here. Let's take the value. Somehow there is some question wherein you are given that you got to have 7 failures until 3 successes. Okay. So it's a negative binomial case if you're having 7 failures until 3 successes. So that means if I'm talking about the probability of the number of tries that I have to take up for 7 failures until 3 successes occur, then the last one is definitely success. Okay. So P cube, it will be because 3 successes are there, right? And since the failures are 7, so 1 minus P to the power 7 is what you will have here. But when you are making that number of cases, how many number of cases? You will have 9C2 number of cases, not 10C3. It's not binomial, it's negative binomial. In binomial, Your random variable is the number of successes. The random variable is number of successes. Here, what is happening? Your trials is a variable. Number of successes are fixed. So that's the difference between the two. That's the difference between negative binomial and binomial. In negative binomial, your number of successes is actually fixed. And because it is fixed, and that is why at the last trial, you have a fixed outcome. चलिए इसी को एक एग्जाम्पल के थ्रू लेते हैं. A pediatrician wishes to recruit 5 couples, each of whom is expecting their first child, to participate in a new natural childbirth regimen. Let P be the probability a randomly selected couple agrees to participate. If P is equal to 0.2, what is the probability that 15 couples must be asked before 5 are found who agree to participate? So what are we supposed to do? In total, we have 15 people we can choose from. But how many couples? What is the probability that 15 couples must be asked before 5 are found who agree to participate? So I require 5 successes. We want to find out the probability that I have to take how many trials? 15 trials in order to get 5 successes. This is what it is. Therefore, if my random variable here, as you can see, is the number of couples to be asked before 5 agree to participate, then that means I'm looking at the probability x equal to 15. What is the probability? I need to ask 15 people before I get 5 people, 5 couple who are agreeing. What is the probability? I just need to ask 15 couples. So that will be equal to, now again, understand, at the 15th couple, you will stop. The 15th couple will be your 5th success. So therefore, you will have definitely success there. Now, once you have success here, you need, of course, if it's the 5th success, I must have had 4 successes before this. So I must have had p to the power 4 anywhere before this. So out of the 14 couples prior to this 15th couple, any of the 4 couples would have agreed. So I can have how many combinations? I can have 14C4 combinations, right? And the others have not agreed. So it comes with probability 1 minus P and to the power 10, because there must have been 10 failures and 5 successes. So in total, this is 14C4, 1 minus P, here is 0.8 to the power 10, 0.2 to the power 0.2 is the probability of success to the power 5. So what you would see is that this is x minus, basically x minus 1, CR minus 1, what we had in the formula here. And that's how you can apply this random variable. Now let's quickly talk about the mean and variance for this random variable, negative binomial. Well, in case x is number of trials needed until including the rth success, then expected value is basically the expected value of the number of trials needed for r successes. Okay. Now tell me something. क्या सक्सेस को पता है कि वो फर्स्ट सक्सेस की सेकंड सक्सेस है कि थर्ड सक्सेस है and so on and so forth? Well, no. So for example, if you are playing a board game and you have a dice and you are gambling that you can only start the game if you get 3 sixes. And so what is the number of trials that you require in order to get 3 sixes to start the game? It could be, if you're very lucky, you might just get 3 sixes in a row. If not, then maybe you're taking 4 successes, 4 If not, then maybe you're taking 5 trials, 10 trials, anything is possible, right? So in that situation, do you think the second success knows that it's the second success? Well, no. So what I'm trying to tell you here is that expectation of the number of trials for our successes could be broken up as the number of trials. So if X is your random variable number of trials for our successes, you can break it as x1 plus x2 plus so on and so forth till xr. Now, what is this? This basically means I am taking x1 number of trials to get my first success. Once I get the first success, I start taking up my trials once again. Then I'm taking x2 number of trials in order to get my second success, so on and so forth. Then I'm taking XR number of trials in order to get the Rth success. And the total would be the total number of trials you've taken to get R successes. So, for example, the case that I gave you, suppose you are taking 10 trials to get 3 sixes. If you're taking 10 trials to get 3 sixes, so it's quite possible, think about it, it's quite possible that I might get my first success in the third trial, and then I might get my second success in the 7th trial. I will have to get, that means, my third success in my 10 trials, because I'm saying that in 10 trials, I should get 3 sixes, right? So this means that I have taken 3 trials for my first success. Then I started playing again and I've taken 4 trials for my second success. And I've taken 3 trials again for my third success. In total, if you will see, 3 plus 4 plus 3 will give you 10 trials, right? That's exactly what I mean. Now, number of trials until the first success occurs. So, x1, x2 till xr. What is the behavior of these? Well, these are nothing but geometric random variable. And of course, it's used in the same scenario. So, the probability is fixed at जो भी है. जैसे यहाँ पर, in this case, it is 1/6. So, वो तो वही रहेगी. वो change नहीं होगी. कहने का मतलब है that expectation of x here is nothing but expectation of x1 plus x2 plus so on and so forth till xr. And these are all independent. Xi's are independent geometric random variable with the same parameter, say p. वो तो same ही रहेगा, एक ही experiment से है ना ये. So therefore, I can use the linearity of expectation and break it up. इन सबका same expectation है. कितना expectation है? Go back to the video to find out the expectation of a geometric random variable. It's 1 by p. Now, 1 by p plus 1 by p plus so on and so forth. 1 by p, how many times? R times. So R by p is basically your expected value here. And अगर आप failures वाला route लोगे, your random variable you will define as failures before the trial, तो थोड़ा सा change आता है, ठीक है, Q भी picture में आ जाता है, but that is a doable thing. If you understood this, you will understand that. Similarly, you can also find out the variance. Now, if you've understood the concept that my X is nothing, but I can break it up as R independent geometric random variable. That's what negative binomial is. So your variance is variance of x1 plus x2 till xr. So therefore it is variance x1 plus variance x2 plus so on and so forth till variance XR. And that means it is, if you remember what turned out to be the variance for geometric random variable. So the variance of any geometric random variable is Q by P square. And all of these are with same parameter. So that means I have R times of that. So RQ by P square is what you get. This is what I wanted to discuss today. Thank you very much.